Today we're going to be reviewing some of the properties of the periodic table. So this will serve mostly as a summary of some of the activities and things we've done so far, but there will be a bit of new information that you want to pay careful close attention to. So we started off when we looked at the periodic table by organizing these big sets of cards. So I gave you all a deck of cards and I just asked you to put them in some kind of order that made sense to you. And ultimately what we came up with was what you see right here, where the cards are increasing in size as we go down the row, or down the column, I'm sorry. We have columns that all have the same color, we have the same number of little sticks that are coming out of it, and so you use all these properties to kind of put them into this order so that we could then relate it to what we see as the modern periodic table. So the next step after this was to examine the actual modern periodic table. And so you had this whole set of elements in the center here, these transition elements, if you remember that name, that we had to insert into the table we came up with. And so that whole set of transition elements is really, really important, but follows the same kind of patterns that we saw where everything in that first row or everything in that column all behaves in the same way. And so at this point, when we were examining this, we went through and labeled what we said were the most important parts of the periodic table. And we gave names to, say, the alkali metals. So the alkali metals was this whole first column of elements. And we know that since they're all in the same column, they all behave the same way. We then looked at the alkaline earth metals. The alkaline earth metals were this whole second column, and again, since they're all in the same column, they behave the same way. The same thing repeats for the halogens all the way over here on the right hand side. The halogens are in green. Whole column behave the same way. Same thing for our noble gases on the end. They're in the same column, so they all behave the same way. After we labeled kind of those major groups, we looked at these things called the metalloids that kind of fall on this staircase as we go down diagonally over on the right side of the table. The metalloids all fell on the staircase. Most of them were attached to it, but there are kind of these exceptions of, aluminum and carbon that look like they're attached, but they're not actually. And so these are the metalloids, and what they do is they separate our metals on the left-hand side of the table. The metals are all over here, right? And the non-metals are over here. They're on the other side of that metalloid staircase. And so all the metals, actually I should have included over here in the metals this section. So these are all metals on the left hand side, all non-metals over on the right hand side, and they make up what is our modern periodic table. These are the things that you wanted to sit down and memorize. They're definitely going to be on our tests coming up. So speaking more in depth about some of those trends we saw, we want to specify what we would call a group or a family. We want to define that. So a group or a family is a special name for elements that are located on the same column in the periodic table. So when we called the alkali metals this first column, we could have called that the alkali metal group. When we said the alkaline earth metals, we could have called that the alkaline earth metal family. And so a group or family is just corresponding to a vertical column on the periodic table. And we know that elements in the same group have similar properties. That's what we use to make predictions about all sorts of elements in here. So the specific example we used in class was copper, gold, and silver all share some similar properties just because they all happen to be in the same column. On the other side, when we look at what's called a period is just elements that are located in the same row on the periodic table. So a period would go across horizontally from left to right. And so this was how we saw those repeated trends. In an earlier video, we talked about why something would be called periodic because it repeats over and over again. And so when we go from left to right across the table, you'd see the same properties happen over and over and over, and then they just restart and happen again from left to right, and then happen again from left to right. And so it's called periodic. They're called periods because we observe those things happening over and over again. That's why we actually call it the periodic table. So just to look at that a little bit closer, the periods, right, we have 1 stick, 2 sticks, 3 sticks, 4 sticks, 5 sticks, 6 sticks, 7 sticks, 8 sticks, and then it repeats. 1, 2, 3, 4, 5, 6, 7, 8, and it repeats again. 1, 2, 3, 4, 5, 6, 7, 8. And so the period, you just see that repeated trend happening over and over and over. Or you can even look at the color, right? Orange, yellow, green, another green, blue, blue, purple, pink, orange, yellow, and it just repeats over and over again. That's why it's called periodic. After we introduced ourselves to that whole view of the periodic table, we wanted to look more in depth at this thing called reactivity, and we said reactivity is just the ability of a substance to react with another substance. So we looked at a video that actually showed us this first set here, the video of the reactivity of the alkali metals. And so you saw in the beginning the first metal was lithium, and it kind of just sizzled on top of the water. And then underneath of that it sizzled again. And then by the time we got all the way to the bottom to cesium, when they dropped it in water, it exploded and blew up the entire container. And so what's happening there is the reactivity is increasing as we go down this column. And so the reactivity in the beginning is like, oh yeah, it makes a little mess. And then the reactivity at the end is this huge explosion. So reactivity is just telling me how a substance might react with another substance. And in this case that we looked at specifically, it was how these metals interacted with water. We also looked at what's called the atomic mass. And we kind of touched on this briefly while we were doing the card sort, but we never really sat down and wrote a formal definition. And so when you did your card sort, you kind of had these little circles, and let's say it had lithium in it, and then there was a certain number down here. Well, that little number we defined, and we said, all right, that's called the atomic mass. And what the atomic mass represents is the average mass of a single atom of an element. So if I had one little lithium, then it would have that mass. And so in this case on here, we look at how it would show up on the periodic table. On the periodic table, the atomic mass is right down here at the bottom. And so for helium, if I had one little element of helium, it would have a mass of 4.003. So the atomic mass is just the mass of one little atom of the element.